Hi everyone, today we discuss about one gate question from 2019 and that is question number 16. The question is basically the number of 1H NMR signal observed in the following compound is, so there is one compound, and how many different type of 1H NMR signal we can observe for this reaction. The meaning of this reaction is that how many chemically inequivalent photons is there. So let's come to the some general introduction. So the first thing is that there is the if there is plane of symmetry, center of rotation axis of symmetry or inversion center of symmetry, this type of symmetry is there, then the protons will be basically chemically equivalent. Okay, they are basically chemically equivalent. So so let's take some example. Let's take the normal benzene. It has C6 axis, sigma plane like these, and there is also a C6 axis. So that's why all the photon are equivalent. That's why we get only one peak in 1H NMR. With some lock system like cyclohexane. If if we freeze the cyclohexane at lower temperature, like say -100 degrees centigrade, we will observe that two different photons at one photon for due to the axial and another photon for due to the equatorial. We normally know the equatorial photon will be more resilient than the axial due to the ring current. So we will observe that at the very much low temperature when the conformation is basically freeze, I mean this type of interconversion is not possible. That time we will show two peaks. But at the room temperature, this type of interconversion is very much rapid. That's why we'll get a average peak in between two. That's why so at room temperature at RT means room temperature we'll get only one peak, but at -100 degrees centigrade, let's say we will get two peaks because due to the log of the conformation. But if we substitute one group like tertiary butoxide, so tertiary butoxide group cannot be stable in the axial position due to the one-stage axial interaction. That time we will observe that these two hydrogen will show two different peaks. Okay. So, and another thing is that if there is any chiral center in the molecule, both the CH2 group will be in stereotropic in nature. So here is the one chiral center, right? So due to this chiral center, these two photon is chemically non-equivalent, and these two photon is also chemically non-equivalent. So due to this, these two photons are basically so different chemical shape in the one H. So now comes to the question. So this is our molecule. So now the question comes: is there any chiral center? No chiral center. But there is the one prochiral center here. If we substitute anything here, this center will be chiral. So there is a prochiral center. Okay. So and now the question comes: is there any sigma CN axis of symmetry? No. I no. But there is a sigma plane center of symmetry like this. There is one sigma plane. Due to this sigma plane, these two CH2 group becomes chemically equivalent, and this hydrogen is also become chemically equivalent. Okay, so the first peak will be observed for this one. This is two, this is three, and this is four. But you will think that due to this sigma plane, these two hydrogen are equivalent. But there is some trick. So we can draw this structure like this. This is a five-member ring here, and we are also drawing a five-member ring. One CH3 group, let's say upside, and aromatic. The portion is like this. Yeah, we have presented by here. So the basically sigma plane is passing like this, right, in between this. So now think if So in this case, these two CH3, this H and this H are chemical equivalent due to the sigma plane. Similarly, this H and this H is also equivalent due to the sigma plane, but these two H are not equivalent because this hydrogen is same side towards the CH3 and anti towards the air. Basically, if we take this hydrogen, let's talk about this hydrogen. This hydrogen is these two CH3 but anti to air. So they will so which group which hydrogen is upside and which hydrogen is downside, they are basically not in the same environment. So that's why these two are not equivalent. So that's why we'll get different peak. So how many peak will get? So this is 4. So we'll get this is 5 and this is 6. So we will get 6 peaks in this spectrum. Okay. So how many quantity signal? We will get 6 signal. Okay. So for more information, you can watch this video. Thank you.